Yeah, no problem.
Okay, so as we dive into the most important pieces, all right, so there may be a quick revision or a minor revision of the study guide, but we want to cover as many essentials as possible. Uh, so we we basically need to understand that a big part of persistence is file system concepts and essentials, right? And so the whole focus of this module, part one, is persistence, part one. We're going to get into a different level, and this is going to be really interesting. I'm excited about this. We are going to have our midterm exam based on module one and module two after we finish the solution and the assessment for module two. So you can anticipate at some point that there will be a midterm exam. It's just going to be a few of our class periods back on the calendar. So it's going to be probably Thursday of next week at the latest. So at that point, we're going to go ahead and get the rest of the other 6 modules, the other 4 modules. So we're talking about persistence part 2, virtualization, concurrence, and firmware and containers. I'm considering changing all that and getting into the troubleshooting of internals. And I'm just doing a little bit of research to make sure, because I want to be sure that the stuff we need to do, I don't want to get into December and we're in finals week of December and everybody's trying to make Kubernetes or Docker work on your virtual machines. And that's what containers is all about. There could be a way to address containers in the virtualization module. And so that's why you haven't seen all of these modules being, that's why they're not all out there. We're doing some refactoring. And another reason we're doing some refactoring is because we're also changing the format so that it flows a little more cleanly with COVID measures that everybody has to endure. But anyway, when you get down to it, you have this security management, the security account management concepts. And we touched on this in module 1. And one of the things that you have to understand is the hand-in-glove relationship between file system objects and the permissions, privileges, and inheritance that comes with that, because those tie into account management. If you have certain privileges or access rights, those are mediated through accounts. They could be user accounts, in most cases they are. They could be computer accounts. But there's a lot of trouble when it comes down to working simple file system objects and file system management and best practices, because people lack the most fundamental understandings about best practices. And so in Linux, you're going to do this again. So the good news is I'm going to walk through some sensibilities about how best to roll out file system resources based on a framework that has to do with accounts, and how you can cleanly and discreetly, in a best practices manner, make sure that people have the privileges and the permissions, and that those permissions and privileges, when we say inheritance, we mean propagate. Another term for this is recursive. In the Linux world, we call it a -R. It's a recursion, right? So you have and what am I talking about? When we talk about recursion and inheritance, I have a C drive. And if I assign a certain privilege to a certain account on my C drive and recursion or inheritance is turned on, it propagates to all of the subdirectories, and inside there to the subdirectories of the subdirectories, and so on and so forth. It filters all the way down. In the Windows world, they want everything to work. So they they enable some default permissions and privileges and inheritance settings. You're going to see that in a minute. Those are set on the root level of the drive, and they propagate all the way down, and see, stuff just works because everybody has permissions and privileges, right? When you get into the world of Macs, and then more specifically Linux, Linux has the reverse philosophy. Unless you explicitly state what an account's permissions and privileges are for a file system object. So in a nutshell, you don't have persistence on a practical level if you don't have some framework, and we'll call that the file system, to structure all of the persistent data storage. And you have to be able to assign those access rights with accounts. And so we get to Posix. Posix is an open standard. If you read the study guide, some years ago, they had, I don't know, 57 different flavors of operating systems. What do we have now? Oh yeah, 57 operating system flavors. But about 25 years ago, quite a while ago, an organization, the IEEE, came out with an open standard that said, you know, in order for us to be able to exchange data, we have to have certain common conventions. And one of our conventions in Linux is that we use the / as a delineator between boundaries for directories and subdirectories, parent directories and child directories, that kind of thing. Does everybody understand what is meant by parent and child directories?
No, can you please explain it?
I'm so glad you asked that. So in the Windows world, in NTFS, in the NTFS file system, NT probably stands for, I don't know, new technology. There's a lot of jokes about Bill Gates and what NT really means. But anyway, new technology file system, NTFS, has been around a while. That's the predominant file system that's used in Windows Server and Windows 10. The / is what we use to separate directories. And at the start of each physical and logical disk, hard disk, is something called the root. Okay? The root. And that's the ultimate parent. We might call that the grandparent. So everything starts with a /. In the Linux world, the same is true, except we don't have disk letters. We don't assign logical volumes or physical disks a letter of the alphabet. We don't do that in Linux. We just have the root directory, which instead of being a / is a /. Now I know this is hard to see, but can you see that image right there?
Yes.
Okay. So if this is the grandparent or root, then each of these are the parents. It's the next generation. So temp could be a parent directory from the, well, I'll call just for an analogy's sake, right? The root directory could be considered the ultimate parent directory, or the final parent directory, the highest parent directory, the greatest parent directory. There's all sorts of adjectives you can use, but you can't go any further. You can't go any, in terms of file system objects, directories, you can't take it past the / or the /. That's root. But then you have directories that you create, and in the Windows operating system, the Windows directory is the default that everybody uses. You don't have to use Windows. You can specify a different directory name to store the operating system, but this is where the operating system is stored. Oftentimes we need to view other settings. So we're going to go into view, we're going to hit hidden items, and now we have hidden directories. Each of these are children of the grandparent, which you could, and when you think about it, what would you call the child of a grandparent? A parent, right? Does that make sense?
Yes.
Yes. So in terms of ultimate file system objects, root is at the top of the food chain, and then you have parents, and then here's your children. The parents have children, and their children have children, so that's, you get to the point where you're like grandchild, great grandchild, you just keep going. So a lot of times relative to each other. Now this, when we have part of a path, this is also referred to as the path. The listing of directories and nested directories, the directories within directories, when you click on this in Windows, it gives you the path. It shows you temp is the parent folder. I mean, if you consider root to be the ultimate grandparent, we're just using that as our, and then that's the child directory, okay? That's what we mean by parent. Does that answer your question?
Yes, thank you so much.
You're quite welcome. So they had to have a way of working, interoperating between operating systems, Linux, Unix, NTFS, old school file allocation table file system, that's DOS, or it's Apple. Now they had, well, Apple had other file systems, so, and that's another specialty topic, but OS X, right? They use APFS. The OS X operating system uses, and they've had several generations, and I can't remember which one's the latest one. They keep changing. But I think the latest one is APFS, could be, or there could be a plus in that. But anyway, in Linux, it's ext4. There was ext3 before that. These, and those are journaling file systems, and that's journaling. That journaling business is something we're going to get into later in the next module, because journaling has huge overhead requirements. What do we mean by journaling? You do anything in a file system, it's logged. A journaling file system means the hooks and criteria, the features and functionality, the file system object specifications, the attributes. Attributes, that's the word I'm looking for. File system attributes, the file system object attributes, and those allow for or include granular criteria so that when you log, you can log anything. I can log who accessed which file historically from which location. And that's because it's a journaling file system. That's a specialty topic. It's an advanced topic. That's why we're pushing that off. But I just wanted you, I want to make mention of it. Here we talk about how you prepare a hard disk. And we started to touch on that in the last session, didn't we? Didn't I have a virtual hard disk and I formatted it? And we chose larger.
Yes, you did.
Yeah, we chose larger allocation file units. So you can't even have a file system. You cannot overlay a file system onto the disk until you do the other stuff. You know, you format it after you, well, you initialize it, then you partition it, then you format it in that order. And that's what's in your study guide. And I hope you take the time to read your study guide. When you format it, you're determining the size. You could just accept defaults, but the inodes in Linux or the allocation unit sizes in Windows, so that you can figure out how you're going to efficiently store the types of files. If you have large chunky files, you want large allocation units and that kind of thing. But after all is said and done, you get to the file system and you have root. And in order for us to see everything we need to see, we're also going to change the view so that in File Explorer, and that's this application here, we're going to, and this is the graphical user version of it. There are command equivalents in Windows and in Linux, and you do a lot from the terminal in Linux, right? But there are also GUIs in there. I'm going to use the options for folder and search options. And the other thing I'm going to do is I'm going to select the C drive at the root, or even better, I'm going to select the PC. So if each disk is like the grandparent, right, it contains the root directory in each. There's a root directory in each of these disks. You could say that the ultimate object here is this PC. Oops, I'm going to change that. In Active Directory enterprise environments, it's the Active Directory domain. It's a distributed security model. That's, again, another advanced topic for the next module. But okay, what we want to do is select this because we want the change in settings to apply all the way down the chain. We want these setting changes to inherit, to propagate. So we're going to go into options. We're going to pick the view, and then we can leave this top one unchecked. If you like looking at thumbnails and icons when you open a folder because you want to know what your JPEGs are, because you get a miniature view of them, you can leave that one unchecked. But you want to check all of these boxes. You want to select show hidden. You want to do empty, hide. No, you don't. You don't want to hide empty drives. You don't want to hide extensions. And you don't want to hide folder merge conflicts or directory merge conflicts. So if you merge directories, you can merge directories with certain commands. If there's a conflict, you want to know about it, you want it to pop up. If your system is not set in this manner, you should do that now. You want to do that on your server, your virtual machine. You're going to click apply, and that's going to propagate from the machine itself into all of the physical disks and logical volumes we call the drive letters that are known by their drive letters. And then as we get into this, if we ever want to see the path, the nested set of directories in our GUI, all we have to do, really, let's go into Windows because that one's really fascinating. We're going to go to System 32. That's where most of our operating system components are. What's that path? What's our path statement? What's the nested listing of parent, child, and grandchild folders or directories? There it is. If you click on it, you can actually copy and paste it. Why am I showing you this? You're going to have to do this to be able to copy this. So I'm going to right click and copy this for commands that we do from within the command prompt for certain things, and especially within the PowerShell prompt. That's the Windows equivalent of the terminal. There are some things there are some things you can only do from the terminal. All right. So are there any questions though about directories as file system objects in Windows? And would anybody care to respond, or does anybody know how many different types of file system objects do we have in Linux? Would anyone care to guess? Crickets. Well, in Windows, you have disks, you have logical volumes or disks, then you have directories, then you have files inside the directories, then you have shortcuts or links, which are like redirects to that file, right? So you have this variety of file system objects in Windows. How many do you actually have in Linux technically? If you're being completely technically accurate. How many different types of file system objects do you operate with in Linux? Should I give you the answer? Are you guys alive? Are we okay?
I am.
Okay.
There's something.
It's a trick question. Did somebody provide an answer? Can you repeat that? Okay, I'll give you the answer. It's also in your study guide. There's only one type of file system object in Linux, the file. Everything is a file. Everything in the file system, technically speaking, if you want to be accurate, in Linux, everything's a file. What do I mean? All right, shortcuts are a file. What about devices? Oh, they're a file. What about directories? Oh, that's a file too. What about disk drives? A file. Yeah. It's kind of weird. Takes a little bit of time to get used to. That's one of those things that we went through in the video. Did you forget the video for independent assignment we already did last week? Please say no. Please, somebody tell me that you remember that being mentioned in that independent assignment. Yes, please, maybe.
Maybe.
Maybe, okay. All right, so when somebody logs in with their account, they're authenticated and they're authorized. So they have an account, they need access on the operating system. They want to really, what they really want is persistence. When you're using an operating system, if you don't have persistence capabilities, AKA access, persistence capabilities is the same way of saying access. Access is framed with accounts. These are file system objects also, operating system objects technically. And when somebody logs in, they have to provide credentials to authenticate, and then file system object access is authorized using those credentials after authentication has cleared. Let's repeat that. I want you to hear the words there. We have accounts, and once we clear our login, we've authenticated who we are, we've established the authenticity of our account by providing a login credential. And now, based on that account, there are permissions and privileges, and then those propagate by inheritance. There were authorizations, which authorization is an equivalent for permissions and privileges. What are you authorized to do? Well, what kind of permissions do you have? What kind of privileges do you possess? Privileges have to do with accounts. An account is privileged. A file system object has to do with permissions. That's an important distinction. I want you to understand that distinction. Privileges has to do with what is the account privileged? What is the owner of that account privileged to? What are their privileges, right? And then, okay, you might have privileges, but are they authorized to have access to the root? No. Well, they have all these privileges. So what? If you don't have permissions, so you have to have privileges to a certain degree, if based on the account, and then you also have to have to frame how this works, the nuts and bolts, the internals of a file system, right? You have to have permissions and privileges, aka authorizations, for specific file system objects, partitions, volumes, directories, files, etc. Okay? Are we good so far?
Yeah.
Okay. Now here's what happens in most cases. People get on a system, they set up directories, and then they start using it, and then if stuff doesn't work, it says you don't have permission, so they change permission settings and everybody goes on their merry way. That's what the world does. That's not what we do. That's not our thing to do. We are professionals. That's why you're taking this class. You're learning a best practice. You want to do something called role-based access control, and it's huge. Put another way, once you understand how role-based access controls, you're going to slice it and dice it and work with it in 100 different ways. That's the hard part, or that's the more difficult part. What often happens is that people go at this, they go at the make it happen kind of thing. Make it so. It's like Star Trek. It's like Jean-Luc Picard in Star Trek. Do any of you watch Star Trek? Do you know who Jean-Luc Picard is? Okay, I'm really dating myself here. And maybe you're not Trekkies. Let's just drop that. All right. In any case, oftentimes people are using permissions and privileges and their settings before they understand the best practice. And here's a best practice, okay? And here's a best practice. We have another object besides accounts. It's called a security group. And computer scientists always do sensible self-documenting things. What do I mean by self-documenting things? Well, let's say a directory has a specific purpose. What's the operating system for Microsoft? Windows. What's the purpose for the directory that contains Windows? What's it called? Windows. Everybody with me?
Yeah.
There are 32-bit system components, the kernel components, the registry. Those are objects. There's actually a database. The registry is a frickin' database. It's an access database. And it has all of the attributes and criteria of file system objects, because they're like the heart or brains of the kernel. It's like the very worst part of your brain. The kernel of the operating system is the brain, and the registry is like, ooh, the deepest part of the brain, right? And one of the things I want you to understand is that it's a best practice to name your directories based on their purpose, or the project they support, or the team they belong to. Now, there is one caveat. Role-based access control, right? If you're in a very high security environment, you may not want to be so obvious about it. So instead of saying top secret credit card data for, for your directory name, you might want to use something a little more, you want to obfuscate intentionally. We're not going to do that until we're familiar with how this works, though. We're going to use sensible things. The other thing you're going to do is that for every directory you create, you're always going to have a security group. What? Yeah. If I have a directory called Project A, I'm going to have a security group called Project A Security Group, right? I'm going to track, I'm going to have sensible self-documenting names for security groups. And there's going to be a comparison, a one-to-one comparison between the security groups I create and the directories I create, okay? Now, what do we do with the security groups? They contain accounts. We place accounts within the security groups. So how do we authorize? One thing you never ever do with role-based access control, right? So what are we saying about, let's break that down. Role-based access control. We're providing access, we're provisioning access with file system resources, and we're doing it based on the role or purpose, the membership of a team, right? You're a member of a team, and your account is a member of a security group, because you, as a person, you belong to a department or a team, and your account represents you on the computer system, on the file system. That's what your account does. Your account is your stand-in. It is your avatar, for lack of a better word. Everybody knows what an avatar is, right? And so you have you have teams of avatars. We would call teams of avatars, teams of accounts, security groups. Okay? Now here's the thing that you never, ever, ever do in role-based access control, and this is always, always, always broken because people don't listen. And I know I'm being crazy about this, but I'm very passionate about this, because if you get it right and you do it right, you'll have so many fewer problems, and you'll be a rock star wherever you go, working with tech, computer science. You really will. But you got to do this, and you got to do it right. You never assign permissions. You never authorize based on a single account. Ever. Never. Ever. You always have a file system object, and the access permissions that are ascribed belong to that security group. Here's one way to think of privileges. A privileged account belongs to high access security groups. The administrator's security group is just such. Local administrators group is a very highly privileged group, right? And if your account is a member of that group, that's called privilege. So privilege has to do with accounts and group membership. Permissions has to do with the access rights or criteria that are assigned to those security groups. And in role-based access, you never do accounts. Now, why wouldn't you do that? Why wouldn't you just have a folder and say, oh, and there is one exception, and I'll grant this one exception. You can have a home directory for a user, and that's the only exception that's allowed. So if each of you have an account, and I'm going to just use another convention, first initial, last name, right? Let's say we have a directory, we call that your home directory. What's the home directory name? First initial, last name. The name of the directory is the same as your account. That's the only case where you're allowed to assign directory permissions based on a user account. It's only for their home directory account. It belongs to them exclusively. It's theirs. Doesn't belong to anybody else, doesn't belong to a group, doesn't belong to a department, doesn't belong to a project. It's theirs. It's where their junk is, right? And that's just, that's where user profiles, that's how user profiles are built. A user profile is technically an operating system object, and that's a specialty topic, and we're going to get in the weeds with that later. But one thing I want you to understand, role-based access control doesn't work if you don't have documents that belong to directories, files that are stored in directories, and those directories 99.9999999% of the time, 1 out of a jillion time, or 9, yeah. It's the only time you don't, the 1 out of a jillion times you don't is because it's a home user account, it's a home user directory, and it's the user account that's prescribed. Does everybody understand this? If I ever see anything you do on your system, your virtual system, where you've assigned a single account, permissions for a directory, it's going to be colorful. It's like the 4th of July or New Year's. I'm going to go off like a rocket. I'm just telling you. It's like, no. Everything goes to hell in a handbasket. There is no RBAC. There is no role-based access control. And that is a government federal standard. Anybody that uses federal money has to use RBAC. Hello? Does UVI receive federal financial aid? Oh, yeah. Oh, yeah, it does. How about territorial agencies? Do they receive federal funds? That would be a yes. Role-based access control is a federal standard, and it is required by federal standards. Nobody knows about this. Everybody gets hacked. Have you seen the newspaper? It's like, oh, the Bureau of Internal Revenue was hacked. Oh, the police department was hacked. Oh, WAPA was hacked. You know why they're getting hacked? RBAC. You are the keepers. This is like the Matrix. You're the key holder, right? I want you to understand, you have the power. If you understand this and you use it, nobody's going to hack you, right? It's a best practice, but it all goes to pieces if you use a single account to work a directory. Now, when I'm saying directories, let's look at something. We should go into here and we should find this one file that has to do with RBAC. It's in the references, and I think it's in the class notes. And I think it's NTFS inheritance notes. Oh yeah, here we go. Can everybody see this screen?
Yes.
Yes. Yeah.
Okay. So on Thursday, we're going to walk through the setup on your servers. And if you can, I want you to check your access. I want you to run updates. I want you to make sure you can log into your server. We're going to share screens. We're going to do it together. But we're going to set up a CSC 410 folder, a directory. Why? And we're going to call it CSC 410. Why? Because we're self-documenting. And we're going to set up a file system object to serve as a parent directory off of the root of our servers. And then we're going to set up 2 subfolders, STT folder for the FTT students. And we're actually going to say STT users, underscore users, CSC underscore 410. And then STT users. And then STX users. And then inside each of those, we're going to set up home folders, personal directories for single accounts. Only instead of having first names, it's going to be first initial last name. Why? Because that's going to match the name of the account. The group names, what do they match? The names of the, now do they have to match exactly? No. But they need to match somewhat. There needs to be a one-to-one comparison. If you have STT users and STX users, you should have an STT users group, security group, and an STX users group. And who has permissions set for STT users directory? Oh, that would be the STT users group. Who belongs to that group? Oh, these accounts, right? So do we assign permissions for Jara to STT? No, not directly. Jara is a member, she's privileged to be a member of the STT users group, which is the security group designated for STT users directory. Does this make sense? Hello?
Yes.
Okay. Now, let's say that I want everybody in 410 to be able to have read privileges, but not execute or change privileges. Does everybody understand what I mean by read privileges or change privileges or execute privileges on a very basic level? Well, let's pretend that we want everybody in CSC 410 to have privileges to read everything in the CSC 410 folder. But when we get to this level, we're going to turn off that inheritance because STT users don't want STX users in their Kool-Aid. Let me repeat that. We're going to create a simple implementation of RBAC with a granular and differentiated permissions, right, based on the inheritance and the privileges and group membership. The users, let's say that STT and STX don't get along. We're just going to pretend. We're going to say Tomians and Crusians don't like each other. So we want everybody that's in this group to have rights to read, but not change it. They can read and execute, but they can't change stuff that's put in this directory. But in this directory, the STT users, and in this directory, the STX users, only these users who belong to this security group have read privileges and execute privileges to the STT users folder. Now everybody can see what's in here, but only people from the STT users group can see what's in this directory. Are you with me so far?
Yes.
Okay, so everybody can see on STX what's in STXs. If I add, now STT users and STX users are members of the CSC_410, CSC 410 security group. But if I turn on inheritance for read privileges here, it's going to propagate. It's going to inherit down to here. And who, other than these users in STT, is also a user of CSC 410? Is that going to keep STX out of STT's Kool-Aid? If I turn on inheritance for the, hey, let's read and execute everything in CSC 410, and everybody that's a member of this, STT users, everybody that's a member of STX users, oh, by the way, STT users and STX users, they're also members of this, right? So everybody by default, by inheritance, up the chain, they're members of CSC 410. If I say, okay, everybody gets to read and execute, and I turn on inheritance, where is it going to apply? Is it going to apply just here? No, it's going to apply here and here. Can I keep STT people out of STX's Kool-Aid? And can I keep STX folks out of STT's Kool-Aid if I turn on inheritance and set read execute up here? What do you think? And it propagates down the chain. If I turn it on here at the parent folder, it's going to propagate to the child folders, which is also going to propagate into the grandchild folders. It means that everybody can read everything. We don't want to do that. We want everybody to be able to read what's in here, but when we get to STT users, we're going to block this from inheriting down past here. Here we're going to set up STT users to read and execute. Here we're going to set up STX users to execute. And we're going to set inheritance so that all of these users in this group can read and execute each other's stuff. Everybody got it? Down here in STX, we're going to turn on inheritance for STX users. Everybody who's an STX user is going to inherit those permissions down here. But when an STT user tries to get into STX, they can't. When an STT user tries to get into STX, they can't. Okay? That's what keeps you from getting hacked. Any questions? Are there any questions?
No.
Okay. All right, so what we're going to do now is close out the class. We're going to pick up where we left off, and then we're going to actually do it. By Thursday, I want you to show me, share your screen as you enter the class. Hey, do you have access to your, yes, here it is. I'm logged in. I got the screen. Okay, show me, share it. And then we're going to walk through creating this infrastructure on each of your servers. And then we're going to share it across the network. And you're going to be able to get in, you're going to be able to get into only the Kool-Aid you're supposed to get into. It's really cool. Then we're going to swing back around and we're going to get back into the study guide and the rest of our inheritance notes. But it all starts with self-documenting, security groups and directories that map to each other, sensible names, and certain restrictions. And then once all that's in place, then you can set your inheritance and repeat. Okay. I'm going to go ahead and stop sharing. And I'm going to stop recording. And then I have to retool for the next class. So thank you all for joining us, and we'll see you Thursday. Good luck with your midterm.